On a quiet Tuesday morning, the world awoke to a stark warning from space agencies across the globe. The sun was entering a week of unprecedented activity. Satellite operators, power grid managers, and airline crews were urged to brace for a cascade of solar flares, coronal mass ejections, and high-energy particles that could ripple through Earth's magnetic shield. This was no ordinary solar storm. It was a critical juncture that would test humanity's preparedness for the volatile star that sustains us. To understand why this week is critical, we must first look back at the Sun's 11-year cycle, a rhythmic dance of magnetic polarity that dictates the frequency of sunspots and eruptions. When the cycle reaches its peak, known as solar maximum, the Sun's surface erupts with dark, magnetically charged regions that spawn powerful flares. Scientists at the Solar Dynamics Observatory have been tracking these patterns for decades, noting that this cycle's peak appears sharper and more volatile than any in the modern record. At the heart of the current alert lies a massive sunspot group, designated AR 3321, sprawling across the solar surface like a bruised scar. Its magnetic field is twisted into a tight knot, a perfect tinderbox for a sudden release of energy. When the magnetic lines snap, they unleash X-class flares, bursts of radiation 1,000,000 times more intense than the light of a standard candle, capable of ionizing the upper atmosphere within minutes. The first of these X-class flares erupted at 3:14 Universal Time Coordinated, sending a burst of extreme ultraviolet radiation toward Earth. Within seconds, the ionosphere swelled, disrupting high-frequency radio communications used by maritime vessels and emergency responders. In the Arctic, a research vessel reported a sudden loss of GPS lock, forcing the crew to revert to traditional navigation methods as the sky above flickered with invisible solar energy. But the most consequential threat comes from the coronal mass ejection that followed the flare, a colossal cloud of charged particles hurled into space at speeds exceeding 2 million kilometers per hour. Traveling along the interplanetary magnetic field, this CME is on a direct collision course with Earth, expected to arrive within 48 hours. When it strikes, it will compress the magnetosphere, inducing geomagnetic storms that can cascade through modern infrastructure. Power grids are particularly vulnerable. The geomagnetic-induced currents can flow through high-voltage transmission lines, heating transformers and triggering protective relays. In 1989, a similar storm knocked out 10 million households in Quebec for 9 hours, costing billions. Today, with a grid more interconnected and dependent on digital control systems, a comparable event could cascade across continents, prompting blackouts that last days. Aviation also feels the sun's wrath. Polar routes, favored for their fuel efficiency, become hazardous as increased radiation doses threaten crew health and avionics reliability. Airlines have already rerouted flights away from the poles, adding hours to travel time and fuel consumption. In 2003, a solar storm forced the grounding of over 1,000 flights in North America, illustrating the economic ripple effect of space weather. Satellites, the silent workhorses of modern life, face a barrage of high-energy particles that can degrade solar panels, corrupt onboard memory, and cause temporary loss of lock on Earth. The GPS constellation, essential for navigation, banking, and emergency services, has already shown intermittent errors. Engineers are executing safe mode procedures, but a severe storm could shorten satellite lifespans by years. Scientists are not helpless observers. The NOAA Space Weather Prediction Center issues real-time alerts, while the European Space Agency runs the Space Situational Awareness Program, coordinating with national grids and airlines. These agencies model the CME's trajectory using data from the twin stereo spacecraft, allowing a narrow window for mitigation measures, adjusting transformer loads, reorienting satellite antennas, and postponing critical launches. Historical records reveal that humanity has endured solar tempests before, but the technological tapestry of the 21st century weaves these events into every facet of daily life. The Carrington Event of 1859, the most powerful geomagnetic storm on record, lit up night skies worldwide and induced telegraph fires. If a storm of comparable magnitude struck today, the fallout would echo through power, communications, finance, and even national security. Yet not all experts agree on the severity of the impending impact. Some argue that modern grid designs, with built-in resiliency and rapid response protocols, can absorb the shock without catastrophic failure. Others point to the increasing reliance on digital infrastructure and the aging fleet of transformers as vulnerabilities that could amplify damage. This debate fuels ongoing research into space weather forecasting and infrastructure hardening. In parallel, private industry is stepping into the arena. Companies like SpaceX and OneWeb are developing radiation-hardened satellite constellations, while startups such as Space Weather Analytics offer AI-driven predictions to commercial operators. Their investments reflect a growing recognition that space weather is not a peripheral concern but a core risk factor for global commerce. Beyond the immediate threats, the sun's activity also offers scientific opportunity. The influx of solar particles provides a natural laboratory for studying plasma physics, magnetic reconnection, and particle acceleration. Instruments aboard the Parker Solar Probe, now skimming the sun's corona, are gathering unprecedented data that could refine our models and perhaps one day predict solar storms days in advance. As the CME approaches, communities worldwide are taking precautionary steps. Emergency services have stocked backup generators, airlines have filed alternate flight plans, and power utilities have briefed technicians on rapid response protocols. In remote Alaska, a small town has installed a magnetometer to monitor local field fluctuations, joining a global network of citizen scientists contributing to real-time data collection. When the solar storm finally strikes, its true impact will be measured not just in flickering lights or delayed flights, but in how societies adapt to a star that can both nurture and challenge. The critical week ahead stands as a reminder that humanity's technological triumphs are still bound to the rhythms of the cosmos, urging us to look upward, prepare diligently, and respect the power of the sun. Beyond the immediate disruptions, the solar storm's geomagnetic impact will ripple through the global navigation infrastructure. High-frequency radio beacons that guide transoceanic flights and maritime vessels will experience heightened noise, forcing pilots and captains to revert to older, less precise dead-reckoning methods. In the Arctic, where magnetic compasses already struggle, the added interference could delay critical supply convoys, highlighting the fragile dependence of modern logistics on a stable ionosphere. The financial markets, too, feel the sun's temper. High-frequency trading algorithms, which rely on millisecond-level data feeds, are vulnerable to latency spikes caused by solar-induced electromagnetic noise. During the upcoming week, exchanges in New York, London, and Tokyo have activated contingency protocols, temporarily throttling automated orders to prevent cascade failures. This precaution underscores how even the most abstract realms of human activity are tethered to solar behavior. On the ground, power utilities are bracing for transformer overloads. The induced currents can cause localized heating, leading to premature insulation breakdown and, in worst-case scenarios, cascading blackouts across metropolitan grids. In response, several national grid operators have scheduled preemptive load shedding and deployed mobile transformer units to vulnerable substations, a silent choreography that keeps the lights on while the sun flares overhead. Space agencies are seizing the moment to study the sun's dynamics up close. The latest solar observatory satellite has been placed into a higher inclination orbit to capture the polar coronal holes that feed the solar wind. Simultaneously, a multinational crewed mission to the lunar far side will conduct real-time measurements of particle flux, providing unprecedented data that could refine future space weather forecasting models. Finally, the public's response offers a glimpse into societal resilience. Schools in solar storm-prone regions have incorporated emergency drills into curricula, teaching children how to navigate without GPS and conserve energy during outages. Community centers are stockpiling solar-powered generators and water purification kits, turning what could be a period of vulnerability into an opportunity for collective preparedness and education.